السلام عليكم.
السلام ورحمة الله وبركاته.
ترى جهزت ولا لسه؟
ايه دكتور جاهزين.
طيب اديكم شير سكرين عندكم دلوقتي. طيب دلوقتي بالنسبة للمجموعة دي أول حاجة سامعين يا شباب؟ في أسامة ده اسمه مش كامل ولا رقمه، فده يتضاف. المجموعة بتاعتكم سموها تيم 1 أو جروب 1، بس كده؟
تمام يا دكتور.
طيب يلا نكمل.
نبدأ دكتور؟
نبدأ.
السلام عليكم ورحمة الله وبركاته. Today we're talking about presentation assignment 1 for thermofluid A2O2.
لا
team
3
member.
دي واحدة بس، احنا 3O2 مش 2O2.
Okay, 3O2.
3 not 2.
Okay تمام. team 1 member خالد الجهني، سلطان بامجدي، عبد العزيز الغامدي، محمد شامي and أسامة.
أسامة إيه بقى؟
I don't know دكتور.
ما تعرفش اسمه أسامة إيه؟ طيب ماشي.
هو اللي ما حضر معنا الحين.
طيب.
Okay, agenda for today: nanotechnology, nanofluid, reset development, purpose, promotion, how nanofluid physical properties can be affected, create and potential use of the nanofluid in the industry.
لا current مش create.
Create.
current مش create.
Okay. Nanotechnology. First, what is the nanotechnology? Nanotechnology is the science, engineering, and technology conducted at the nanoscale, which is about 1 to 100 nanometers, and study and the application of extremely small thing, and can be used, of course, in the other science field, such as chemistry, biology, physics, and material science and engineering. What as do? How it started? The nanotechnology started in the 1959 with the physics Richard, but it is can do see the atoms in the atom in the material. But how we can see in the 1981 by Professor Noer development the scanning microscope to see the atom in any material. Second, nanofluid with my friend Abdulaziz.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Abdulaziz Al-Ghamdi, and today I will be presenting nanofluids. Nanofluids are just fluids containing nano-sized particles, which can be designed and engineered to serve different functions. It is also considered as the future of heat transfer fluid. They are expected to give better thermal performance than conventional fluids due to the presence of the nanoparticles which have high thermal conductivity. Next slide, please. Types of nanofluids. Nanofluids can be classified into 4 distinct categories based on the type of dispersed particles. Metal nanofluids, metal oxide, and metal hybrid, and carbon nanofluids.
انت بتتكلم على نانو بارتكلز ولا بتتكلم على نانو فلويدز؟
لا، أنا بتكلم عن النانو فلويدز يا دكتور.
طيب بس هو اللي انت حاطه ده عباره عن types of nanoparticles.
ايوه، النانو فلويد هي تقسم بناء على النانو بارتكلز بتاعتها. هذا المعنى.
طيب كمل بس.
Next slide please. These are some applications of nanofluids in heat transfer field. Number 1 is microelectronics. The second one is fuel cells, pharmaceutical processes, engine cooling, vehicle thermal management, and domestic refrigerator.
هل الحاجات دي potential use ولا this is actual application?
No, this is actual application.
Okay.
Next one. Recent development. Recently, the focus is shifting towards improving the quality of heat transferic particles. And there are some other recent projects includes heat exchanger and cancer therapy, lubricants, oils, and metal cutting operation. I will leave you with my friend Sultan.
Assalamu alaikum.
عليكم السلام.
The main goal of nanofluids is to achieve the highest possible thermal properties at the smallest possible concentration. It's most preferable to be less than 100% by volume. By uniform dispersion and stable suspension of nanoparticles should be preferable less than 10 nanometer in host fluids. To achieve this goal, it is vital to understand how nanoparticles enhance energy transport in liquids. The combination of nanoparticles and base fluids can produce many heterogeneous nanofluids. As you can see, the nanoparticles material may include oxide ceramic, metal carbides, nitrides, metals, nonmetals, and layers. While on the other hand, the base fluids may include water, ethylene, coolants, oil, and other lubricants, biofluids, and polymer solutions. Next page, please. There are 2 steps to produce the nanofluids. It's called 2-step and 1-step method in same that order. 2-step method is most widely used in nanoparticles and nanofibers and nanotubes, or any other nanomaterials are first produced as dry powders with chemical or physical processes. Then the nano-sized powder is to be dispersed into the host fluid as second step with one of the following process. It should be intensive magnetic force agitation, ultrasonic agitation, and high shear mixing, homogenizing, and ball milling. This mode is the most economic one to produce nanofluids in large scale because nanopowder sciences technologies have already been scaled up to industrial production level. For the 1-step method, It consists of, at the same time, making and dispersing the particles in the fluids. With this method, the process of drying, storage, transportation, and dispersion of the nanoparticles are avoided, or in correct word, must be avoided. So the agglomeration of nanoparticles is minimized and the stability of fluids is increased. This step process can be prepared uniformly depressed nanoparticles, and it's used in the small scales. Next page, please. And now we'll continue with my friend Khalid.
Assalamu alaikum, everyone. Now I will talk about the effect on thermal
انت خالد الجوهني؟
ايوه دكتور.
انت مش بدأت في الاول ولا كان واحد تاني؟
لا اللي بدأ محمد.
طيب ماشي.
Now I will talk about the effect on thermal conductivity by type and concentration. First, the thermal conductivity of the nanoparticles can be affected by several factors, since many preparation parameters can be changed from the characteristics of the nanoparticles to their stability in the fluid, as well as other properties of the suspension. All those factors contribute directly or indirectly to induce the variation in the thermal conductivity. A brief description of the effect of two factors in the thermal conductivity I will talk about in the following minutes. First, the type. Different types of nanoparticles have been tested, such as metals and metal oxides and ceramics and carbon nanotubes. Some reports indicate that the thermal conductivity of the nanoparticles is less relevant to increase the nanoparticles than in heat transfer rates, while others suggest that nanoparticles with higher values of thermal conductivity may increase the heat transfer in the nanoparticles. For instance, compare the thermal conductivity of water-based nanofluids with copper and aluminum nanoparticles. The greater enhancement of the thermal conductivity in the copper nanofluid was attributed to the higher thermal conductivity of copper. On the other hand, observed a greater enhancement in thermal conductivity using a water-based nanofluid with TiO2 nanofluids than when using Al2O3 nanofluids, despite the lower values of the thermal conductivity of the TiO2 nanofluids. And the second effect I will talk about in the concentration. The increase of the particles concentration enhances the thermal conductivity due to the greater interfacial area between the base fluid and the nanoparticles and increasing agglomeration, and report says an increase in thermal conductivity by increasing the nanoparticles concentration. Also observed a linear relation between concentration and thermal conductivity using water-based copper nanoparticles. And using nanoparticles of Al2O3 and CuO measured experimentally the thermal conductivity of the nanoparticles at low volume fraction range.
فين الجرافس بتاع دي يا خالد؟ يعني الحاجات دي كلها كويسه، الكلام ده انا عارفه كل حاجه. يعني الكلام ده المفروض ان هو يكون فيه ليه جرافس توضح الحاجات دي، ديفرنت تاثير التايب وتاثير الكونسنتريشن. هل عندك الجراف دي في سلايدز؟
لا يا دكتور، انا في السلايد خليت يعني اقل شيء ممكن.
ما اقصدش يعني بدل ما يعني انت بتحكي الحاجات دي كلها في بعض الفيجرز بتوضح لك الحاجات دي كلها، واخد بالك؟ طيب شوف
أيوة.
اللي بعده بعد كده ايه تاني؟
اكمل يا دكتور من مكان وقف؟ طيب هذه يا دكتور النقطة اللي هي حق أسامة، بس أنا راح أكمل.
طيب ماشي، ده اللي هو البوتنشال يوز والكرنت يوز. ايه بعد كده؟
أيوة. Okay, now I will talk about the current and potential use of nanofluids in the industry. The advanced concepts of nanofluids offer fascinating heat transfer characterizers compared to conventional heat transfer fluids. There are considerable research on the superior heat transfer properties of nanofluids, especially on thermal conductivity and convective heat transfer. Application on nanofluid industries such as heat exchanging devices appear promising with this characterizer. Nanofluids can be used in following specific areas. One, heat transfer nanofluids and turbological nanofluids and surface and cotton nanofluids and chemical nanofluids and process nanofluids and environmental or pollution clean nanofluids and bio and pharmaceutical nanofluids and medical nanofluids. Nanofluids can be used to cool automobile engine and welding equipment and to cool high heat flux devices such as high power micro tubes. And a nanofluid coolant could flow through tiny passages in MEMS, which means micro electrical mechanical system, to improve its efficiency. And the measurement of nanofluids critical heat flux in a force convection loop is useful for unclear applications. And nanofluids can efficiently be used for a wide variety of industries. Next slide, please.
The next slide.
This is our assignment, and if there is any question, please ask.
طيب هو دلوقتي بس عشان ايه حاجتين. اول حاجه هو الشغل بتاعكم انتوا عملتوا شغل كتير بس في حاجات ناقصه. اول حاجه مفيش اي فيجرز، يعني حاول انت يكون في عندك جرافس او فيجر توضح الكونسبت الحاجات اللي موجوده عندنا اللي انت اتكلمت عليها. خلاص كده. الحاجه الثانيه الفيجرز اللي انت مستخدمها زي 1 ستيب و 2 ستيب مانيفاكتشرنج للنانو فلويدز او اي حاجه شبيهه ليها، المفروض انت بتكتب الريفرنس انت خدته منه، واخد بالك، وتضيفه لل
دكتورة، الريفرنس في نهاية البرزنتيشن موجود هذه.
يعني انت جبت الفيجر اللي هو بتاع 1 اور 2 ستيبس ده منين؟ من واحده من دول، مش كده؟
ايه
خلاص يبقى بتحط جنبه بتكتب كده مثلا method of مثلا manufacturing or creating nanofluids، وتكتب جنبه مثلا اللي هو ريفرنس بتاع رقم 1 أو 2 أو 5. اوكي. الحاجه الثانيه، انت هنا اغلب الحاجات دي الريفرنسز دي المفروض ان انت جايبها من اماكن معينه او ويب سايتس، ومش كاتب اخر مره اكسس للسايت نفسه، واخد بالك. المفروض انت بتكتب لاست مثلا فيزيت، او تكتب التاريخ اللي انت اخر مره عملت اكسس للداتا من الموقع. خلاص كده؟
ايه.
طيب
تمام.
في اي سؤال تاني؟
دكتور،
ايوه
أعدل الباوربوينت وأرسله لك؟
ايوه
طيب
بس اكتب بقى كده جنب اسامه، اكتب اسمه بالكامل واكتب ان هو ما حضرش.
أبشر.
ماشي. بس اللي بعده. وانتوا بالنسبه لكم انتوا تيم رقم 1. خلاص
تمام يا دكتور، تمام.
اللي بعده المفروض يكون تيم رقم 2 ويبدا دلوقتي.
دكتور، نحن تيم واحد فنحن جاهزين يعني. نبدأ يا دكتور.
التيم اللي هيبدا دلوقتي هو تيم رقم 2. خلاص
طيب دكتور، مش مشكلة، تمام.
عشان بس ما نتلخبطش يعني. تيم 2 ويبدا دلوقتي، يلا. اللي هيبدأ سليمان دلوقتي ولا مين؟
ايه دكتور موجودين.
طيب
محمد سوي الشير من عندك. سامعني محمد؟
انتوا
واضح
التيم بتاعكم
الشير.
كام؟ 6؟
ايوه دكتور.
طيب يلا ما شاء الله يعني. كلكم موجودين؟
بس عبد الله مو موجود.
عبد الله كان مثالي هو اللي ما اعرفش هل ده اللي
أرسل
بعت
لك.
لي عنده ظروف.
ايوه أرسل.
ايوه
طيب نبدأ دلوقتي.
طيب السلام عليكم ورحمة الله
عليكم
وبركاته.
السلام.
This is Mohammed Tifruti from Team 1 and from Team 6, and I'll be introducing nanotechnology, inshallah. In the International System of Units, the prefix nano means 1 billionth or 10 to the power of 9. Therefore, 1 nanometer is 1 billionth of meter. It's difficult to imagine how just small that is. So I'll give some examples. A sheet of paper is about 100,000 nanometers thick, and the human hair is approximately 80,000 to 100 nanometers wide. This figure shows size comparisons between known things and nanoscale objects.
اي ايمج بتستخدموه لازم تحط الريفرنس بتاعه يا محمد.
It's here, doctor.
انا مش شايف
National
حاجه، انا
Center
شايف
of
ايمج ومش شايف اي ريفرنس ليه.
National Center of Electronic Microscopy.
طيب يعني كده كفايه ولا المفروض ان انت جبته من بيج معينه، من صفحه معينه، من سايت معين؟
From their original website.
طيب ما هو تكتب بقى في الريفرنس، تكتب السايت وده تديله نفس الرقم بتاع الريفرنس. خلاص
إن شاء الله.
طيب اللي بعده. الكلام ده كله طبعا بالنسبه لكل الفيجرز، الايمج بعد كده او فيجر بعد. ماشي
تمام.
طيب.
Nanotechnology is not simply working at ever smaller dimensions. Actually, working at the nanoscale enables scientists to understand and utilize the unique physical, chemical, mechanical, and optical properties of materials that happen at this scale. When particles are created with dimensions of about 1 to 100 nanometers, materials properties can change significantly from those at larger scales. This size scale where quantum effects can rule the behavior of properties of particles. An interesting and powerful result of quantum effects of the nanoscale is the concept of tunability of properties. This concept says that by changing the size of the particle, scientists can literally fine-tune a material property of interest. At the nanoscale, properties such as melting point, fluorescence, electrical conductivity, magnetic permeability, and chemical reactivity can change as a function of size of the particle. Regarding the surface area, nanoscale materials have far larger surface area to volume ratio from bulk materials. As surface area per volume increases, materials can become more reactive, as can you see in the top right bottom. In biology, nanoscale is the scale at which much biology operations occur. Many of inner workings of cell naturally occur at the nanoscale. For example, hemoglobin, the protein that carries oxygen through the body, is 5.5 nanometers. A strand of DNA, one of the building blocks of life, is only about 2 nanometers in diameter. It's really difficult to list all applications of nanotechnology. Applications of nanotechnology are delivering in both expected and unexpected ways. Nanotechnology is helping to considerably improve, even revolutionize many technology and industry sectors. Information technology, homeland security, medicine, transportation, energy, food safety, and environmental science, as many other fields. Nanofluids, the next with my friend Sulaiman.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Sayyid Muhammad Akamuddin. Today I will talk about nanofluids. What is nanofluids? Basically, nanofluids is superheat transfer in fluids. So nanofluids is a new class of heat transfer fluids engineered by dissolving metallic and non-metallic nanoparticles with a typical size of less than 100 nanometer in base fluid. Nanofluid is used in many applications in industry. So it depends on performance and stability of nanofluids used in the system. Types of nanofluids. We categorize the nanofluids based on type of nanofluids used in fluid. Metal, metal oxide, carbon, metal hybrid. Hybrid fluids prepared by bending using two different kinds of nanoparticles in the same fuel. To have a greater thermal conductivity, physical, higher heat transfer than simple nanofluids. There is another classification also based on nanoparticle, ceramic, bare metal, alloy, carbon. Why we use nanofluids? We use nanofluid, as we mentioned before, because they have high heat transfer, better than normal fluids. They can use easily in many applications, has a better thermal performance than normal fluids due to present of nanoparticles in the same fuel. Okay, next. Nanofluids has a unique electric magnetic chemical properties than normal fuels. Types of nanoparticles involve aluminum oxide, magnesium oxide, zinc oxide, and they use nano fluids in industrial because they easily produce heat than normal fluids. Next. How to prepare nanofluids. The first method, two steps method, it's very common and very widely used in industry to make nanofluids, nanoparticles, nanofibers, nanotubes, or any other nano materials. In this method, we use the nanoparticles as dark borders to make nanofluids. The one-step method. There is also another techniques, but the most common one industrial, the first and second approaches. Next, how to produce nanofluids by two steps method. We bring the nanoparticles from different materials, nano-size them, make it as a border to dissolve in the base fluid. Also to avoid unwanted resulting from casting the nanoparticles in the fluid, we use simulation or distribution to avoid this unwanted result. Next, there is a table for examples for method of preparing nanofluids by using oil and carbon, water and copper. Next, please. Stability of nanofluids. Nanofluids has more stability than normal fluids, but when we prepare nanofluids, sometimes there is casting or irrigation of nanoparticles in the same fluid, so we must remove this castle from fluid to get a high performance of thermal conductivity of nanofluid. And thanks, I leave you with my friend Omar. It is my reference.
just بالنسبة ارجع تاني السلايد اللي قبل كده. انت عاملين كذا ريفرنس في كذا مكان ولا هو ريفرنس في مكان واحد؟
Every part has its reference.
لا المفروض كله يتحط في مكان واحد، وتحط برضك اللي هو اللاست فيزيتد لكل ويب سايت. ماشي؟
اوكي.
وزي ما قلت برضك بالنسبة للايمجز لازم تحط عليها الكروس ريفرنس مع الحاجات الموجودة. ماشي؟
ماشي.
يلا بعد كده.
Okay, السلام عليكم. My name is Umar.
انت رقم
Today I
كام في
will talk
المجموعة؟
about أنا رقم 3.
3؟ لا أنا قصدي يعني دلوقتي كام واحد عمل برزنتيشن من المجموعة بتاعتكم؟
إحنا المفروض 6 أنفار. أنا الآن الثالث.
الثالث؟ طيب ماشي.
Okay, today I will talk about the development and application of nanofluids. We have some applications here, nano medicine and electronics and chemistry and thermal transport process and the optics. Next slide, please. I will talk about the thermal performance of nanofluids. The heat transfers is classified into various mechanisms such as the thermal condition, the thermal convection, and the thermal radiation. In a device field that transport is a critical parameter to the obtain effect performance of machinery and devices, as the solar collectors. A is a flat plate solar collector. B, vacuum tube collectors. Next slide, please. A solar collector is a device that collects concentrated solar radiation from the sun. These devices are primarily used for active solar heating and allow for a heating of water for personal use. We have 2 points here. السلايد اللي قبله. Solar collectors' thermal energy storage components are the 2 nuclear or kernel subsystems in a solar thermal application. 2, these collectors are generally mounted on the roof and they must be very sturdy as they are exposed to a variety of different weather conditions. Next, please. Here is a flat plate solar collector. These collectors are simply metal boxes that have some sort of transparent glazing as a cover on the top of a dark colored absorber plate. The next one. Here, the second one is vacuum tube collectors. This type of solar collector uses a series of vacuum tubes to heat water for use. These tubes utilize a vacuum or a vacated space to capture the sun's energy while minimizing the loss of heat to the surroundings. And I will leave you with my friend Ammar.
مو جزئيتي يا عمر.
هم؟ عمر مش موجود؟
ايوه يا دكتور.
موجود ولا مش موجود؟
جزئية مين هذه يا سليمان؟
إيه؟
لا موجود يا دكتور، بس هذه مي
موجود موجود. جزئية مين هذه يا سليمان؟ سليمان.
معك
هذه جزئية عبد الله محرز اللي غايب اليوم.
طب ماشي، اعملوا بتاع ده براوزنج ليها كده ووريني اللي فيها عشان نخلص مرة. طيب definition nanometer size. طيب بالراحة بس كده. طيب اللي
ارجع
بعده، اللي بعده بس هنا. طيب كمل بعد كده. طيب كمل اللي بعده.
جزئية ثانية دكتور.
دي حاجة تانية؟ طيب ماشي.
لا انتهت.
ايه؟
انتهت الجزئية خلاص، هاي جزئية
طيب.
جديدة.
طيب بس دي كان المفروض تكون في الأول خالص، يعني في الترتيب بتاع
اللي هي
يعني واضح إن أنتوا السلايدز نفسها أنتوا كل واحد عامل حاجة في حاجة
دكتور
مركبة.
احنا مشينا على الترتيب اللي في البي دي اف حق الاساينمنت اللي
طيب
هو
ماشي.
نفسه، مشينا عليه عشان كذا.
طيب اللي بعده كمل.
خلاص دحين دكتور جزئيتي.
كمل الجزئية اللي بعده كمل.
يعني أنا خلاص start. Okay. But my name is Ammar. I am I'm studying aerospace engineering, and I'm with team 2. Today I will present physical properties of nanofluid. Next, please. Okay, introduction. I will start with the introduction. Thermofluid provide a situation of change the energy of system. Heat transfer efficiency of this fluid depends on their physical properties such as thermal conductivity, viscosity, density, and specific heat. To you, the thermal conductivity of the traditional thermal flow like water, ethanol, glow, and oils. Nanofluids is a substance of fluid particles in size nanometer in vast fluid to increase the thermal capacity. Next, please. What are the main physical properties of nanofluid? We have 4 physical properties: thermoconductivity, viscosity, specific heat, and density. Next, please. I will start with the thermal conductivity. Thermal conductivity is a heat transfer fluid that are commonly used, such as oil and water. As a result, fusion studies have been connected to improve the heat transfer conductivity of this fluid by boosting their thermal conductivity. The addition of the nanoparticle of a high thermal conductivity salt materials to nanofluids result in a high thermal conductivity. Next, please. The thermal conductivity of nanofluid is described by multiple equations in the lecture. The thermal conductivity of the nanofluid employing the base fluid was improved by 5 to 10% according to the most notable finding, based on the particle size and best flow thermal conductivity. There is no significant improvement in the thermal conductivity as compared to the traditional burst flow. Next, please. Thermal conductivity. For Cartier study, traditional models of efficient thermal conductivity of substances have been published, like this equation you can see, and I will define the parameters of this equation. K EFF is the efficient thermal conductivity of the substances. N is the shape is a shape vector of the nanoparticle. V is nanoparticle volume fraction. Km or Kc are the thermal conductivity of subsisting medium and solid particle. Alpha and beta are employed finding parameters which are finding as the equation that you can see. Kc over Km and alpha minus 1 over alpha plus 2. Next, please. Also, we have the viscosity. One of the factors that affect the behavior of nanofluids is their viscosity. Based on their research with the viscosity nanofluid, they have published assumed equation to limit viscosity. Next, please. Here is the equation for collecting equation or example that have been reported by some research. The model is valid for sphere nanofluid particle and for alpha between 0.52 and 0.474. Meaning of alpha volume fraction and mu, it is dynamic viscosity. Next, please. Density. Density is the density of a material is defined as its mass power per unit volume. In heat transfer, density play a Cartian role. As many scientists believe that the increasing in the density cause increasing in a natural convection. Next, please. There are many researchers used mixture rules to calculate density of nanofluid. And here you can see this, the long equation. The nanofluid density raise as the particle volume conductivity raise. And Rehar report an increasing in a density near 3.5% and 4.7% for the particle, growing from 3.5% to 5%. In Expenser using nickel water nanofluid. However, mass, rate, and temperature have the opposite influence in substance density. Next, please. The last physical properties is specific heat. The heat energy required to raise the temperature of a unit quantity of a substance by a given temperature interval is measured by specific heat capacity, also known as a specific heat. It's another signet thermal physical feature along with the others. Nobody can deny that it has an impact on Barnett number, its capacity per unit mass, and has transport in general. Material have a low specific heat than liquids. As a result of the low specific heat of nanofluid, we can say that a decrease in specific heat of nanofluid as compared to pure fluid. As the particle from conductivity increase, the specific heat of the nanofluid drops. Next, please. And here is the equation that you can calculate the specific heat of mixture. Mixture long 2007 suggests a formula which flowing mixture formula, and this is the equation. Next, please. And here is the reference. I use PDF book, and I use Australian journal based on 1991. And thank you for listening. And now I will leave you with my friend فراس.
فراس انت اخر واحد في الجروب ولا لسه في واحد تاني بعد؟
ايوه اخر واحد.
طيب ماشي.
السلام عليكم. My name is Faris. Today I will talk about current and potential use of nanofluids in industry. heat transfer in natural convection. A nanofluid separates two surfaces where heat is conveyed. There are many examples for of industrial application, which is electronics and solar collectors and heat changers. Next. There are two types of tanning of the nanofluids using a dispersant, which is thermal the conductivity measurements and viscosity measurements. Next. Phase changing materials as a component of nanofluids. If the temperature of the phase change falls within the temperature range of the heat transfer process, materials that change their phase used as particles in the liquid could provide one mechanism to achieve this increase. Next. Reduced conductive heat transfer in the nanofluids. If correctly tailored the process, nanoparticle system dispersed in base fluids may give highly specialized solutions for certain heat transfer jobs. The consequence is that the application must be determined first, followed by the development of a nano tailored to the application. Next. Thank you for listening. If you have any question, ask, no hesitation, please.
اوكي، في اي استفسار يا شباب ولا كده خلاص؟ الناس اللي موجوده معانا. طيب عموما يعني ايه الملاحظات اللي انا قلت لكم عليها تعملوها. الحاجه الثانيه طبعا انتوا عملتوا شغل كويس، بالذات الموجود فيه كبير. لو في عندكم في بعض الجرافس سبورت الشرح اللي عاملينه يبقى احسن كده. ماشي ان
شاء الله.
يلا سلام عليكم. المجموعه اللي بعدكم.
دكتور نقدر نمشي ولا؟
اللي خلص ممكن يمشي، بس انا عايز اشوف بس اللي هو مين موجود دلوقتي والمجموعه اللي هي تعمل برزنتيشن.
تمام يعني دكتور يوم الربوع ان شاء الله حنسوي الكويز ونشرح
ان شاء الله
assignment 2
هنشرح الاساينمنت وناخد الكويز
ان شاء الله. وانت طيب.
فين بقيه فين المجموعه اللي بعد كده؟
السلام عليكم يا مهندس.
سلام.
مهندس
المجموعه اللي جايه دلوقتي المفروض مجموعه 3 جروب 3 او تيم 3.
ايوه احنا جروب 3 بس مهندس شوف احنا كنا 5 طلاب ونقصنا طالبين سحبوا الماده فصرنا 3 طلاب. تمام.
ده سحبوا الماده
بعد كذا جاء والله يا دكتور ما ندري بس انهم اختفوا من عندنا، كنا 5 وطلعوا من الجروب.
لا اختفوا مش معناه انهم سحبوا الماده.
ايوه
يعني عندك اسماء دول اسمائهم ولا ما عندكش فكره؟
في حسين جلال يا دكتور. وفي واحد ثاني اسامه.
طب عموما لما تبعت لي البرزنتيشن اكتب لي اسماء الطلبه واكتب ان هم صاحب الماده او حاجه بحيث انا اتاكد.
طيب يا مهندس بس عشان تكون في الصوره، كان معنا طالب رابع كمان في التيم كان مسؤول عن تنظيم البرزنتيشن. بس انه ما رتب اي شيء، فالشغل اللي موجود شغل بس تجميع كل الجزئيات مجمعه فوق بعض بدون تنسيق.
يعني انتوا
يعني كل واحد جاهز على جزئيه.
انتوا مش جاهزين يعني.
كل واحد ايوه دكتور بس يعني الشغل ابدا مو مرتب يعني.
طيب
نكون واضحين من البدايه.
طيب. انتوا بالنسبه لكم يوم الاربعاء ان شاء الله ممكن حتى بعد ما نخلص يبقى اقول لكم على ميعاد نقعد تكونوا جهزتوا شغلكم ونقعد فيه ونشوف الشغل بتاعكم. خلاص؟
اوكي.
طيب مين تاني معانا؟
شكرا دكتور. دكتور بس ممكن استفسار بس التوتوريال الأخير ما ترسل لنا، ما وصل لنا الفايل. توتوريال كويشنز والريفيجن كويشن ما وصلت لنا.
طب ابعت لي بس ايميل وقول لي
تمام.
ايه اللي ما وصلكمش واخر حاجه وصلت لكم يعني.
طيب حاضر إن شاء الله.
يعني اللي هو الريفيجن كويشن.
الريفيجن والتوتوريال الأخراني، آخر توتوريال اللي
هو
حق
الريفيجن
الكونفيجن.
كويشن، هو الريفيجن كويشن ان هم كانوا سؤالين والتسجيل بتاعهم.
لا التسجيل وصل، بس إنه الفايل نفسه ما وصل لنا.
خلاص. طب ابعت لي بس، قول لي بس على
تمام شكرا يا دكتور.
في حد يعرض حاجه دلوقتي ولا كده؟ انتوا في مجموعه تعرض حاجه دلوقتي؟
لا اعتقد خلاص يا دكتور كده.
خلاص كده. طيب عموما المجموعه اللي هي كانوا بيقولوا في ناس انسحبت منها، في كم واحد فيها دلوقتي؟
3 فقط.
3 هم كنتوا 5 مش كده؟
ايه
كنا
معنا واحد
6
رابع يعني
بس معنا رابع يا دكتور، بس انه مو شغال معنا.
لا، في حاجه اسمها في واحد شغال.
ايوه يعني
اسمه
دخل
يتحط.
امس معانا لانه ما لقي جروب فما اشتغل معنا.
يعني دخل كده وبتاع ده، حط اسمه بس وخلاص.
ايوه قال انا بنسق ومن الكلام ذا، ولنا الحين ما قام
يعني عامل مدير يعني. الكلام ده ما ينفعش، يعني الكلام ده ينفع لسه بدري قوي عليه لما يعمل الحاجات دي يعني. لا قولوا له يشتغل، يا اما بتاع ده تشيلوا اسمه.
تمام يا دكتور.
بس يعني وحاجه من الاثنين، في شغل يعمله، ما فيش شغل اسمه ما اتحطش. بس
تمام
خلاص.
تمام.
طيب المجموعه اللي هي فيها مشكله دي، عايزكم اول حاجه تبعتوا لي ايميل بالاسماء الطلبه اللي هي انسحبت او اللي انتوا اللي هم انسحبوا يعني، وشغلكم دلوقتي زي ما هو. انا مش هديكم درجه عليه، بس على الاقل اعرف بالظبط ايه اللي انتوا معاكم في ايديكم. ماشي
تمام.
واليوم الاربعاء ان شاء الله نتفق على ميعاد بحيث تعرضوا الشغل بتاعكم. فانتوا دلوقتي كنتوا المفروض عدد الجروب او الطلبه كلهم في 19. خلاص. فانا دلوقتي المجموعه الاولانيه كانوا 5، الثانيه 6، ادي 11، وانتوا 5 مع اللي مشوا، فكده يبقوا كام؟ 16. يبقى في مجموعه ناقصه، يعني في مجموعه منكم مختفيه خالص. ففي مجموعه انا مش عارف بالظبط هي موجوده فين، او ما حدش اتكلم منها النهارده. فيوم الاربعاء او لو في حد ما حضرش منهم قول لهم بس يبعتوا الشغل بتاعهم، على الاقل يبقى ايه اثبات حاله، يعني يبقى عندي في ريكورد بيه ان هم اشتغلوا وخلصوا الشغل. موضوع ان هم عملوا برزنتيشن ما عملتوش الموضوع تاني دلوقتي. واضح؟
تمام.
طيب اي استفسار دلوقتي؟ اي سؤال؟
شكرا دكتور.
طيب يلا سلام عليكم.